So 5000 means 4 into 500, 2000. So the data type value is 2000, and its the allocation of memory is continuous, like the address is 04 like this. So it will be continuous like this. So this is the address name of 1000, 1004, 1008, 1012. So this is how. And the questions, if I want to declare 5000 variable, I can go for array. And in there are some difficulties in array. In array, we can't able to resize the array values. If I created a 5 integer data types into the array, but I can able to but I want to use 3 remaining values can be assigned as 0. So and the data type and the address of this variable, and the address of this variable is the address of the first variable of the array. First variable means, so this is 1000, right? This is not, this is address, right? So this address belongs to d4. So like this, if I need to access this values, I can able to go for wait, oh, just wait a second. I'm going to open my code. So here I'm going to array. So in this program I am going to explain array. So this is the syntax, and this is how we declare an array variable, and inside this value represents what are the how many values we are going to store, like how many data types need to create inside the array. So if I need to print the address of the each variable of array, I can use for loop. You need to just remember one thing, and the thing is, if you are taking for array, if I need to print the values of array, I need to use for loop. So if array means for loop, you need to remember this. And the range of array values is the index values is 0 to n minus 1. So these values can be accessed by the for loop only. So this is how, and this addressing operator returns the value. And here if 0 means first 0, so here 0 assign, so 0 will assign here, and then array value of 0. If percentage d means data type value will return. And execute this program. GCC, sorry, cd sorry, C program, cd error array. So I'm running the first program. So here, okay, an error. So a warning comes, but no problem. So it brings the integer data type of the value. But in case I need to know the actual value of I need to have actual address. So how the address can be stored in RAM means I can go for %p. So it executes without any errors, no errors. So this 0 starting 0 to 4. So how many bits? How many bytes of integer data type? 4. So 0 to 4 and 4 to 8. And then this is go for 8 plus 4 what 12. 12 means C hexadecimal value. So and 12 plus 4 again it one comes to 0. So this is how the address can be determined. If I want to print the decimal values like this, right, I need only a 4, right, but I need 2, so I can go for HU. So this 7, these values are what? Negative values, not positive values. How I can able to find the positive values? So I can use unsigned input, unsigned format, unsigned format specifier. So with the help of unsigned format specifier, we can able to print the positive values of this. Now I get the positive value. Then I need off. So I can use the specifier of HU. So it will give the 2 bytes of data. 2. I need 1 byte of data. I can go for HU again. So this is how address allocation 2. So 20, 24, 28, 32. Now you can able to easily understand, right? 16 into 4, 20, 20 into 4. So this is how we can able to so this is how we can explain the array. So this array variable also have a address. Let me do this percentage %p /n comma addressing operator array.